All right, just a quick review of absolute value. Recall that the absolute value means distance from zero. So how far from zero something is. So if we looked at a number like the absolute value of x equals 5, we know that on 0, if I look at 5 units from 0, there's the number 5, so it's there. And on the other side, 5 units from 0 is the opposite of 5. So we know x can be 5 or x can be -5, right? 5 units from 0. Now, the way we're going to change up is we're going to put this inequality. So now when we say the absolute value of 5, or the absolute value of x is less than 5, let's go back to our number line. All right, plot 0, plot the number 5. We know that all these numbers, 4, 3, 2, 1, and all the numbers in between, meet the restriction here that the absolute value of that number is less than 5 or less than 5 units from 0. So I'm going to put an open circle on 5 and a solid line for all of those values. We'll look at the other way. We've got this -5, all right, so open here, but we know all of these numbers, -4, -3, -2, -1, are less than 5 units from 0, so we have to include those numbers too. So if we wanted to rewrite this equation without the absolute value, we know that x has to be less than 5, but it has to be greater than a -5, which really means two equations, x less than 5 and x greater than a -5. So we can solve equations knowing that. So in general, once you see this absolute value of x is less than some number b, you can immediately rewrite the equation as x is less than b but greater than -b and move on. All right, another thing I want to go back here and realize that this written as interval notation up here is -5 all the way to 5. So a number line here using b, you get 0, b, and -b, all the numbers in between. So we know that the interval from -b to b satisfies that equation. All right. The next thing to think about is how about the other way around? How about when we say the absolute value of x has to be greater than 5? Well, once again, let's look at our number line. All right, put 0. So this means it's got to be more than 5 units from 0. So if we plot 5, now we know all the numbers outside of there, 6, 7, 8, 9, 10, on. So open circle over 5 and all those numbers. All right, but once again, we look at the other way. How far from 0? So we look at the number -5, which is 5 units from 0, right? And then all the numbers outside of that, -6, -7, 98, 10, whatever. So it's that way. So if we were to write this, now we have two equations. We have the equation that says x is greater than 5, but this one says x is less than a -5. And once again, if we were going to write the interval notation, I would say from negative infinity all the way up to -5, union 5 all the way to positive infinity. So if we're going to generalize that, if we're given the equation, the absolute value of x is greater than some number b, we can get rid of the absolute value sign by saying x is greater than b and x is less than the opposite of b. Once again, you go back to your number line, convince yourself of that. Here's the number b units from 0, so everything above. Here's the other number, b units from 0, and everything below. And if we write the notation, negative infinity to -b, union b to positive infinity.